All right, so hi, this is Nancy Wilkins-Deere. I'm sitting here in San Diego with Doug White, who is a professor emeritus at UC Irvine, just up the road here, and Paul Rodriguez, another collaborator on Doug's Science Gateway. Doug, I think, first came to well, you've been involved with the Supercomputer Center for a very long time, but more recently it was the Summer Institute, I think, maybe just this past summer?
2 years ago.
2 years ago, and kind of got involved with some optimization work with some people in ECSS, and then in some gateway work with Lucas and Roshana out at University of Chicago, and Tom Uram previously to that. So Doug's definitely explored a lot of the different options in the ECSS program and is making a real difference in his field. And we're excited to have him on this call today. He's also going to be, he and Roshana and Lucas are also going to be presenting on next month's symposium call. But really kind of groundbreaking work, I think, that they're doing in this field. So I'm glad you are all able to join us here today. Doug, do you want to, here, I'll get the phone near to you.
Okay, so I can give you some instructions to go to a page called InterSciWiki. Spell this the way it sounds, one word. And there you'll have the URLs that were made by Lukasz. I'm sorry, the YouTubes made by Lukasz. One will explain how we use the conventional kind of gateway saving files, which has been very, very useful to us. That's a 2-minute YouTube. And then the other one is a longer YouTube that was made for our conference 2 weeks ago in Albuquerque, where we called the conference Celebrating the Solution to Galton's Problem, and has another number of other features, which are extremely new in actually solving the problem of taking autocorrelation out of the kinds of modeling that people do with observed variables. So this site is filled with databases from anthropology at the moment, cross-cultural, and some of the work that was at that conference and will be shown here is going into the Wiley Companion for Cross-Cultural Research, but it really generalizes very deeply into the social sciences, the problem being that most of the data modeling on observed variables have a high degree of autocorrelation, and without solving that, you don't have any validity, particularly in the significance test. Sometimes you can get the correct coefficients, but most samples in most fields that use observed variables are massively overestimating significance terms. So that means all the models end up being partially invalid. And in our field, it's about 50% of the findings are have invalid significance tests. So I'm going to show you this one example from our conference. It's an example which I did with colleagues in the first slide, and then at the end, Paul Rodriguez, who's sitting here next to me, worked with me on using Bayesian, the Bayesian network library, BNLearn. And from there we went on to a number of features that will be in our next submission to continue the project. Rather than using the virtual machine that is our Galaxy, we're going to be using Trestles directly. The difference in time is you can run a class. We have run a class. There's a typo there. It says the first class was 2003. It actually was 2013. So the students can use a 2-minute turnaround in regression to keep improving their model. And also in the slide by Lukasz, which explains how to use the saving results, they were able to put all of their results week after week, letting the instructor who's in China and letting me, who's in La Jolla, look at what they're doing and give them some suggestions. And then at the end of the term, they've finished and they have a project. The introduction to the course being the subject matter, and then the conclusion being the use of the gateway. So we're aiming at a much higher level now of complexity. And I should say this is, if you look at my bio, for example, half of what I do there, I would like to say almost everything, because the other half that's going to go into the Gordon version of this gateway will deal with complex networks. So if you include networks, then everything that I do is basically covered between networks and studies of systems of variables. So this slide, which is one of about 20 for empires that have kind of bracketed by external events. For example, this case is an early Chinese empire. These are studied by a geneticist who wrote the book on the dynamics of population rise and fall with respect to resources in biology. He is kind of the most advanced statistician in that field of study, and he switched to study history. And this is one of the diagrams that shows how population, relative to resource, the kind of Malthusian variable, rises and falls until it hits the end of the empire, the end not being extinction, but being the change to a new empire. So there are two variables here in addition to time, which is T in the equation. There's a 25-year lag of the effect of overpopulation given the resource base, producing social conflict and inequality. And then there's a crash period, and the crash is characterized by conflict or warfare. So I have P in my equation, W for warfare, and a 25-year gap, that you see in the theory-based variables there. And this is an oscillatory system in the long term. And at the bottom of these declines, the social collapse of a giant polity, what you get is a recovery period and a new period of innovation beginning a new cycle, often with a different political system in place. But at the bottom of these collapses, what you tend to get is inequality that's sufficiently severe so that new forms of religion are not only being proselytized, but being accepted widely in the population. So in the lower left, we see a phase diagram of these two variables, and then we see some of the characteristics of these variables as rate changes. And that's the basis for the, well, here's an example, but those periods of collapse and regeneration of religious beliefs, which include, of course, Christianity, and they include Islam, and in this case, they include the conversion in the Han Dynasty that we were looking at, from Confucianism to Buddhism and Taoism. So let's go to the next slide. And so these are the concepts for the anthropological data. This is the standard cross-cultural sample we're looking at. It has 186 cases. It's one of 4 databases currently in our data set repository, any one of which can be called and use the same statistics. Here, for settled communities, the stability of a system, that is everything going on in one community, because it's settled, and then having wages in that community, which is not terribly common, but about a quarter of the sample has wages. And what happens in these periods of decline, you get overpopulation. And given that it's a settled community, you have owners of property, and they benefit in a time of scarcity because their holdings increase in value. Well, the people who do not own and are basically taking wages for labor are by definition in this period of overpopulation and scarcity of resources, they are penalized by lowered wages because they're in an oversupply. Now, the same thing happens with the empires and societies of pastoral systems. And here the idea is that the big owners of camels and horses, for example, the groups that ran the great trade routes between China and Europe, for example, the Silk Roads, those large lineages basically owned the productive property, that is camels and herds of camels and horses. And the lesser lineages were maybe large, but less in terms of owned resources. They would be, for example, the people who ran, the herders and the people who ran the caravans. And they are also in a unequal, in a period of collapse, in an unequal position, particularly if there is an exchange relationship, such as the wealthy lineages taking some of their herds and using bride wealth to acquire more wives. In other words, they can then have the advantage of increasing their population size, but also creating for the other lineages a situation where not only is labor underpaid and their resources become more and more scarce, but they lose women and reproductive capability. Okay, there's a third variable, but I'm going to go on. So this is really worth looking at in the context of the InterSci Wiki, which has more about the method. But basically, this is a slide that condenses in a very severe way the idea of getting rid of autocorrelation. What you do is you take variables like distance and language and religion or other things. Actually, you only need a few for these matrices, the autocorrelation matrices, which are square matrices. They're named W matrices. And the way they're used is you take a matrix of inverse distance, for example, and you normalize the rows to 1. And so they all have 1 on the rows, which means when you multiply this matrix by a variable, you're going to get a weighted variable which reflects the similarity between cultures on that dimension. Now you do a regression across the W matrices in these, having been multiplied by the variables X, a set, and Y, the dependent variable. And you forget all about the characteristics of individual societies. They're not represented. All you have left is, what would I be like if I was only a reflection of everybody else in the mirror? And that applies to both the dependent variable and all the independent variables. And when you do a regression, you get an estimated, it's that little Y hat with a sub W. That is that estimate becomes the control for autocorrelation. And usually just a couple of strong matrices will remove autocorrelation as defined by other statistical tests. So now we're going to go ahead, another slide, and we're going to let the actual regression, these are both OLS, or ordinary least squared regression. Now you have the original Y variable, but what you've stuck in the equation in addition to the normal, B sub 1, 2, 3 regression coefficients for the x variables, you are going to have a new variable which is already been done. It's going to be weighted in the regression, but it's that y hat w. And that simple addition means you have two OLS regressions in succession, and the findings are that this typically removes autocorrelation, but there are a number of tests to see if that's true. So it's not necessarily true. It's not automatic. Now, this completes the model that I'm going to show you results for. But I'm going to go further, and with Paul's input here, we did a third stage of regression where one of the things being done in the statistical package is imputing all the missing data from all of the variables, both the dependent and the independent, or there's an option to do only those that are coded for the dependent variable. So let's move ahead. And this is the result of the two-stage least squares, or two-stage OLS, ordinary least squared regression, for the variables in the model. And below the variables and their regression coefficients and significance, you get some of the diagnostics. This is not the complete list, but the diagnostics in this case have no significant p-values, which means none of them are telling you that there are problems in the model. If we look at the significance, the stars, 1, 2, or 3 stars for different p-values, we see variables that have been selected because they are significant, but among them are the theoretical variables, animal times bride wealth, which is an interactive variable, multiplying those two variables, and community with wage labor, which means you've got a interaction going on between owners and workers that is disadvantageous in a time of scarcity. And you also have a no rain, scarcity of water variable, and you have some temperature variable, and you have a size variable, productivity, and writing in records, which might indicate something like societies that have taxes where you'll have an imbalance. And then you have a kind of control variable, missions, and usually Christian, and a weird Freudian variable that I didn't expect, which is the distant father. Oh, we leave the weird variables in. We'll worry about the theory later. It doesn't mean that some of these variables are not fallacious. Anyway, but I kind of like that feature. Let's move ahead. Now, this now forgets about the model, and it says, hey, let's just do straight linear regression, ordinary least squares, on the imputed variables. They have been calculated, and so this might be the same as above, but in fact, the variable that was hardest to code, the fixed community wages, kind of the most common agricultural and state system variable, might have been a little poorly coded because it was not the subject of the major studies that did coding of this data set. It's kind of filled in by another external imputation, looking at sources fairly quickly and doing an estimate. And that variable actually gets better. So here you see that the imputation is improving the variable. And then if we go one more, but it's not exactly the same. One more, here we see that variable in ordinary least squares would not even, it would be absolutely random. And in fact, none of the variables are significant at any great extent. So what it's telling you then is that the system is working and it's getting a better model, and that OLS would not possibly be able to get this model. So let's go ahead and now do something more. So that is the equation for the third stage regression model. And since we have those variables, we just rename them, given that the H $ data are the imputed variables. And then we go up to this kind of really still third stage, but let's just, now, so here what we're doing is we're comparing two different published, well, one published model is on the lower left, and the model that we've been looking at is on the on the lower right. The one we're working with right now is on the upper left, and this is Bayesian network learning. It's an algorithm that took all of our library, BN graph. This took all of 6 lines of code to produce, and what it's telling is that our two of our key variables, the community wages and animals with Bridewell exchange, both have a credible Bayesian property in the sense of Judah Pearl and all the other work that's been done on Bayesian graphs. This algorithm has only been out since January, and there are 9 other approaches with 9 key characteristics, of which for each of the other libraries, they are missing on 6 or 7 of the major features, and can be considered incomplete. This latest algorithm solves all but one problem. The one remaining problem actually has been solved, is whether you have discrete or continuous data. So what you see there is one model is performing remarkably better than the other, but there's a segment of it which is not connecting to the dependent variable, namely dryness, writing or taxes, and missions. Now it makes sense that missions is not causal of religious transitions. They already occurred. One could do a study of why the missions are there. And apparently the writing and taxes is not creating the conditions. Actually, I don't know of any cases anyway. But the no rain dry had been found in a previous study. The co-author Snary had found various kinds of scarcity. So let's move ahead here. Those are just some crosstabs. Now, Paul's work comes in. I had wanted to go ahead and study, instead of having a dependent variable, to study networks of variables. And so I asked Paul if he would look into the algorithm, BN learning, and about a week later he comes back with the 6 requisite, having read, we both read the literature, but he knew how to read it better than I did by far, and so he came back with the first Bayesian network. Now, he went on and did a bootstrap procedure in which you basically are replicating 1,000 times the calculations and then using a criteria of independence, which is what Judah Pearl and others use. Of course, that what you really want is non-independence, but the independence, non-independence creates clusters within this set of bootstraps, and so he clustered them, and then we can go on one more and see the simplest bootstrap with the highest probability was exactly the one we saw before. High God, the dependent variable, and the 2 theoretical variables interactive. Of course, you have to have theory to put a direction on these arrows. So obviously, high gods are not causing features of agriculture or features, well, they could be, but it's very implausible. Now, at somewhat lower level of probability, the rain variable comes in, and this makes sense as a potentially causal variable that affects pastoral systems more than the agricultural system. Let's hit it again. And here, to me, this is the most interesting. The probabilities get very low on the bottom half, but basically you see the same results. There's a cluster where you have the main effect up on top and the no rate and dry, and then you have a few things like writing has a 30% probability of whatever. And that's basically the end of this, I think. Let's see if there's anything else. No, okay. So let's switch now and say, okay, now we have in the data set itself, let's see, what can we go to?
Do you want Suresh to bring up the page and we can kind of walk him through
let's do it.
Yeah.
Okay.
Should he start off with this URL here, the XSEDE Compute, or?
Yeah, let's do that.
Okay. Suresh, do you see the first link that I sent to you? Actually, I'll make you a presenter here, okay?
Yeah, sure.
And then if you bring up the first link that I sent, I think, that's going to bring up the gateway, and
Sure.
Doug can walk you through what to click. Hang on a second. Okay, you should be a presenter now.
Sure. So I'm trying to share now.
And if somebody could open a website called InterSci Wiki, we'll have some of the key links that are there.
Yeah, let me, I'll broadcast that guy to the group too. Let's see.
Oh, Nancy, I think I know I get the same error message like what you get.
I know, I never got that before. I know.
Yeah,
it's really.
Okay, let's just broadcast it.
I
we'll work through it.
Yeah.
We'll work
I
through
ran
it.
the test. I ran the test and it goes through fine. It is weird.
I know, it's, yeah.
Sorry. I can quickly try one more browser, Nancy, if you want me to. If you can take back the presentation, I'm now logging in back.
Oh, yeah, sure. Yeah, I know, it was frustrating because I was quite sure that I had done that recently too, that I've been able to share the screen, yeah.
I just ran the test and it ran through everything and said now you can successfully present. And then when I actually do it.
Yeah. Yeah, you almost need to run through everything from start to finish before every single video con these days, unfortunately.
So if you look at...
There's a couple, so actually also on the other... I broadcast...
If you want to quickly try my other account, sorry.
Yeah, sure, yep. Okay, the one with your last name?
Yeah.
Okay. Okay, you're a presenter.
Yeah, it looks like this is working.
Looks promising.
Can you see my screen now?
Yep.
Okay.
Great, excellent. What browser did you use?
I used for Firefox and it worked.
Interesting. All right.
Okay, so now this is the main page, and the YouTube, if you click it, tells about the use of what's in the upper right corner. And here we have an unnamed history, and that's 2 minutes. Makes sense to actually use it because it's guaranteed by Lukasz Luczynski, who has done the second part of the programming following Tom Urim the first year. So
there's audio to that too, Suresh, but folks can watch that on their own, I think. It's
Since Doug was speaking, I just muted. So, but I think for the benefit of everyone, I think what's interesting, what you're seeing is you might have seen Galaxy Gateway in different contexts, mainly bio, mainly where it was originally developed. So these are interesting exercise where Tom Urim originally took Galaxy and then helped Doug build his gateway using the Galaxy portal framework, and then now Lukasz inherited that and been continuing to do that. So.
Yeah, so it's Galaxy applied to a completely different field. Lukasz is on the ECSS Gateway staff, so he's picked up the work from a previous ECSS staff member. The nice thing here too is that there's a lot of nice things actually, but so Some of this is going to be incorporated in an online textbook published by Wiley that Doug referred to earlier, so you can read about something and then you can go do the problems. You can share histories with others. That's one of the nice features of Galaxies. It was originally built to ensure reproducibility. So say you publish a paper and you describe something that you've done, folks could go to this Galaxy site and easily redo exactly what you've done. You can share histories with other people. That's some of what these videos talk about, is importing histories and rerunning things. And we have sort of the low-cost things running on the UC Irvine web servers, and the more compute-intensive jobs running on Trestles, and also when they hold this for large numbers of classes where people are running simultaneously. I think they use Trestles then also, and reservations and things like that. So it's, I don't know, this is an interesting talk for me because we don't often hear about the computational aspects of a field like anthropology. So even just the networks and the variables Doug was talking about, I think probably to a lot of us on the call, that's an entirely new field, and it's pretty exciting for that reason.
Okay, now on the InterSci Wiki, there's a link to this site, but also there are links to the two YouTubes, and then in the end of that paragraph, there is a link to the example that I just gave, where it's a link to what was saved as a saved history, and in that history, Lukáš explains that basically you give it a name and then have an option to save it. I saved it in a public way, and when we went there, it shows the whole history of what I was doing before up to the model we just saw. And basically Nancy said, okay, so how do I make this work? Well, there's a link where you say, okay, now move this over to your own page where it becomes part of the Galaxy XSEDE Gateway. And XSEDE Galaxy, I should say, because it's being run on a small machine at this point, and the more complicated things that I discussed that we're working on with Paul Rodriguez are going to come in full-fledged hundreds of variables at a time, networks of variables, run not only at Trestles, but being bootstrapped at Trestles. So we'll have a lot of alternative models, and we can use Aki information criteria and BIC, the Bayesian version of that. And we have a bootstrap version in my mind today of path analysis with bootstrap. And what that means is our mathematician who is developing the mathematical model for a for a path analysis with observed variables is going to start with the imputed data. And the problem with doing a lot of variables in a path analysis is you have to get rid of the non-independence between models, that is, you're combining models in a sense. And then you have to make sure that you have IID statistical criteria approximated in the error terms. What that means is, in all of these models, if you're just using regression, you can eliminate the autocorrelation, which is a correlation between the error term and the variables model, the independent variables. When you combine different models, you don't have that because you have one variable that has independent variables that might be correlated with the error term in a different model, and that throws off your estimate. But you solve simultaneous equations to get rid of that, and then you get nervous if you're the mathematician, very nervous. And so having solved the problem in my imagination today, I'm going to go back to him and say, okay, but don't worry about those errors, because we're going to bootstrap it, and we're going to find out what the different models are that are generated probabilistically and which ones have this high ID approximation, and that's going to be one of several outcomes that you'll have. Now, for that, you need Trestles probably running quite a while, not just a few seconds, but quite a bit of computer time. So I think that takes us up to where we are in the history of this project. We're going to put in a new application in July to do that next step, everything you saw in the slides, and then this idea for... So this is something entirely new for anthropology. The point is, it's also something that can be used in any discipline that has observed variables. Well, how many disciplines have observed variables? Well, all of the social sciences, some of them are fields of experimentation, but most of them do observe variables. That's what they do. So this is open, the only, to use by uploading data sets. But there are two things that have to be done. They're fairly simple. You create your W matrices, because hopefully you know where these places are, or people are. And secondly, you have so you need to create those matrices, and then you use, to do imputed variables, you need to have some set of good fully coded variables that have been factor analyzed. So you have a bunch of factors, and they are used in the autocorrelation. So it's not too hard to set up databases, but it takes those two steps, and then any field can use this system.
Yeah, thanks, Jack. I think all this is very interesting to many of us who are in we've been used to the conventional gateway style, like Sudhakar Pamadikancham, who is on the call, runs, where really they are the more compute-intensive, more obvious compute-intensive domains like chemistry, molecular dynamics, and so on. So this is nice, new, and refreshing to see some of this. And then we also have on the call Sergio Senelvisi, and who leads the novel and innovative programs within XSEDE, and this might be interesting for Sergio and his team also to take to some other disciplines who haven't been using or building gateways for their domains and try to use this as an example.
So in order to support this, we've first added, in the process of adding a new virtual computer at the Santa Fe Institute with the expertise to take over when needed on a project from our outstanding contributors of the code that goes into a gateway, into a galaxy, actually. We're going to need our own people, and we're kind of designating. We have a group in England that might be able to do this, but clearly the people running the lab at Santa Fe Institute are capable of this. So that is in process. And then the second thing, so we want to kind of distribute those, because if you have 1,000 students working at the same time, they will crash the system. On the other hand, all of this, from courseware point of view, is going to be relatively small classes, because the instructor has to monitor people through the shared histories. And of course, you can't do that for 1,000. So this is not a Stanford MOOC. Mm-hmm. This is intensive courses. They can be from high school level up to postdoc level, or of course a lot of researchers will use this. But so we want to be able to get some of the heavy load over with complex models where you can learn more about larger sets and networks of variables. But we also need to multiply the number of independent virtual machines that can serve. And then there's no limit to what we can do. We may find ways to get around the crashes that happen when 4 or 5 students use this simultaneously. But then we want to build a community that has all of these other observational social sciences in them. So we see sociology as a big, we've had sociologists in our group at the first conference. We've had econometricians, and they do, observe variables when they model real systems. And then we have political scientists who are looking at network aspects of international political science. it's probably better to use these approaches with larger data sets, that is, global data sets. Why not do the whole globe as well as instead of one case? But we have a diachronic element, that is a time series element of the project that is being developed in terms of databases, and there are ways that we can combine things like path analysis with time series, not necessarily, well, the new project is taking time series like we saw in slide 2, but this project itself, where each observation is at a particular time period with particular observers, but you can stratify those and control for time by stratifying the analysis. So we see this as leading in a lot of interesting directions, very coherently and compactly, so long as we get the computer configuration right and don't worry our mathematicians too much. But they're doing a great job so far. None of this needed to have worked out, but the statistics of controlling for autocorrelation, having passed a lot of the critical tests, are looking like they're working very well, and they ought to work for other kinds of data sets.
It seems to me that this helps the state of the field in that once you have good models available to everybody through the gateway, you don't have people developing their own code on their own laptops and maybe making those same mistakes that make the mathematicians nervous kind of over and over in lots of independent ways. So it's kind of, it's kind of nice you're giving everyone state-of-the-art tools without them installing and keeping things up to date and optimized. Paul, I don't know if you want to say a little bit about what you did. Paul is working on this as a member of the Gordon team, I think, right? Gordon or Trestles, but not ECSS per se, but Paul's also done a lot of work on the network analysis. I don't know.
Well, I mean, Doug said it pretty well.
Yeah,
I mean,
okay. The porting to the new machines and...
I mean, it was pretty straightforward because we're running this in R.
Yeah.
There was, there's nothing particularly tricky about it. So I'm not sure.
Yeah, I think
Doug really covered it. I mean, I think the point about how this lends itself to other fields, other social sciences, is I think really important. I mean, this actually, the bootstrapping idea for on top of a Bayesian network in the context of learning a network of variables came out of or became kind of more prominent in this in computational biology. There's a thing called the DREAM competition. They've been running for several years now, specifically looking at network discovery. And they're the ones who say, hey, this bootstrap's working really well in that context, whether you do it over Bayesian network or something else. Anyway, and so Doug's idea of applying this to path analysis is completely on track. I mean, that's the right kind of thing to do, at least certainly in the computational biology context, and I think in many contexts. So Bootstrap has been around for a while, as people know.
Yeah, great, thanks.
We have questions from the audience? Or is it just you, Suresh, up there?
I think.
Oh, we have all these people here.
Yep.
Oh, great. Well, look, any of you are welcome to contact me good. There's Marlon Pierce.
I have a question.
Yeah, go ahead. Is that Sudhakar?
Yes. So, is there a way to bring in data, either in databases or personal data into these tools?
Yes, for sure. All that's needed is that the data set be accessible. We use Dropboxes because it's a little premature for us to have a complete R. All the code is in R, but to do an R package, we're going to wait a while on that. That'll have databases and code in it, and that should have some way of doing the two steps I mentioned, namely to have some complete data set, a subset of variables where they're selected to kind of cover the range of phenomena that are central to this discipline, and then factor analyze those so you have enough independent sources for the imputation. The imputation, by the way, is absolutely standard usage. It's MI or MID, which is used in all the national surveys in the U.S. By the standard kind of regression mathematician. Not regression, but imputation guy. So then the other, I think it's fairly trivial. I've done it myself to take your location data and your whatever historical data about interconnections. You can use phylogenetic analysis, but those two steps are all that's needed to put a database up in theory, and I'm happy to help people do that. And we have a team. Our econometrician has handled all the data packaging problems and is really very brilliant at that. So yeah, this can be applied, and I'd like to see it applied by people coming in from different fields, and we can perhaps have meetings or online. I've learned, like Nancy, to use this thing called what did I discover? Let's see, good 10-person
Google Hangout.
Google Hangout, for example. We can do a Google Hangout with a number of people instead of flying to a conference and solve some of these problems.
Yeah, that would be a nice extension to the gateway. I mean, right now I think everyone's been concentrating on just getting this working for a particular field, which is obviously what you want to do first. But then there might be links on the gateway where if you'd like to upload your own data sets and run your own analysis, I think you always want to get something working well first for what it was intended to work for, but that would be an obvious next step and kind of a nice thing to do.
Yeah, we've had no problem whatever using the same code. And by the way, that code is accessible as our GUI, so you can do a bit of tinkering with it. And one of my bright ideas this morning driving over here was, gee, why not, if you don't specify which autocorrelation variables, why not have the program default and just do OLS for you, which means now you can do what I did in my talk without using much of the supercomputer energy. It takes about 10 seconds to do that. Have imputation, well, you can use the imputation code. But yeah, I'd like to kind of form, Suresh is the person who suggested this to me, that we're going to need communities to support this. And as you know, there are not a lot of mathematical anthropologists. There's me and my student who did the math on this, standing.
So maybe some outreach is needed to other communities.
Outreach, yeah. I mean, it's not that we don't have a lot of users. This is a huge field. There are tens of thousands of studies using cross-cultural data. But they use OLS and SAS and SPSS, and it's all flawed. There are even belief systems that say, oh, gee, if we get the sample small enough, we don't have autocorrelation. Well, that's absolutely not true. You have clustering in almost all naturally observed. And what are you going to do? Go around and say, okay, you animals, you stay far away for several generations, maybe for thousands of years, and then we don't have any autocorrelation. Well, you can't, experiment with the world that way. So every field has this problem. And we just don't know of any conventional software that has solved this problem before. So we have to thank Malcolm Dow, who was my student, and we worked on simulations, and we found out just how severe the problem was. We also measured autocorrelation, and we found out, again, just how severe the problem is. And then if you go to surveys or political entities, there is no independence out there. That's what science is about. So not independent entities unless you try to create an experimental situation. So we need a larger community to think about these problems and see how this affects different subfields. Sorry for this sermon.
No, we're all learning something here. I don't know if there are any other questions. Suresh, I'll have to shut down the web conference at the top of the hour. I've got to do an interview then.
Sure.
I think we're, and I did get it recorded, so we'll get it out there on the web too.
Yeah, I'll take care of that, Nancy, once you log
Okay.
in. Yeah,
Great.
and then thanks, Nancy, for hosting and then helping with that, all of the logistics.
Yeah, sorry I couldn't do those. Doug couldn't do the live demo right from here. I'll definitely look into that for next time.
Yeah, and also, also a couple of plugs. Nancy said, like, the ECSS symposium, maybe we can all learn, like, how the Argonne team, the Chicago team has actually modified Galaxy and to accomplish this. And thank you, Doug. I know you said, like, you're heading out on international travel and you want to do this before that, so it nicely worked out. Thanks for doing that.
I thank you so much for doing it. It was only one day advance notice that I had because I was doing things at this other conference, which was wonderful. That was a great time saver to have only one day.
That's right. Yeah, you don't have a long time to agonize over the
Oh, you mean the last time? Okay. Yeah. Okay, thanks, Nancy. I think that's it.
Okay. Yep. Thanks, everybody.